remind me from yesterday, what did we get for the measure of angle A?
Angle A
Was 65. Very good. What did we get for the measure of angle B?
115.
115. Angle C?
65.
65 and angle B. Okay, hold on. With us, please. So we had 65, 115, 65, and 115. So what was our conclusion? Good. Opposite angles. Absolutely. We notice here that our opposite angles are congruent. So remind me, would that work for a square as well? In a square, would my opposite angle still be congruent? Yes, absolutely. Okay? And then we asked to add angle A and angle B together. So what's 65 and 115?
180.
180. What is that called? Supplementary. Why are they supplementary? Okay, but why are these equal to 180? Because they are what kind of angles? Consecutive interior. Good. So here we're talking about angle A and angle B. These two angles right here. These lines are parallel. This line is called a transversal. These two angles are on the inside of those parallel lines, and they're on the same side of the transversal, which is what makes them consecutive interior angles. I'm not going to go any further, but we talked about this yesterday. Same thing with CD and CB, correct? They're still consecutive interior angles. Now what I'd like for you to do, I'm going to give you a couple of seconds, and I want you to go in and measure the measure of angle DAC. DAC. So if I have A, B, C, D. Again, this is the graph for the white project paper that we're looking at. The graph for the white project paper in our booklet, right? And they want me to measure the angle of DAC. This angle right here is what they want you to do. What's this line called? Diagonal. The diagonal. So now they want me to use the diagonal. What do you know about that angle? How big was angle A? 65. So is this one going to be bigger or smaller than 65?
Smaller.
Good. Now I want you to use your protractor, and I want you to go measure that angle. And then I want you to measure the angle next to it. And then I want you to measure the angle up here and over here.
Rewind.
Okay, so we have 25 here, 40 here, 40 here, 25 here. What does that tell us? Let me ask a question. What if this line is parallel to this line? What's this line right here called? Good. What do we know about this angle and this angle? They're the same. Why? They're alternate interior angles. Absolutely. They are alternate interior angles. And what do we know about alternate interior angles?
They equal 90 degrees.
No.
No.
No, because 40 and 40 isn't 90. They're the same. They're congruent. Absolutely. And then if I look at the other direction, I have this line is parallel to this line, so that would be my transversal. And now I have this one and this one. Are those also alternate interior angles? Yes. Okay. So we're having to go back and remember some of those fun things. I'm not going to worry about us measuring this one because it does the same thing, just using this diagonal instead. So I'm going to give you 30 seconds, and I want you to look at number 4. I'm going to give you 30 seconds. It tells us that it's a parallelogram. So think about all the smart things you know about a parallelogram. And 30 seconds, go. Hey, somebody tell me the first thing. What was the first thing you saw?
80 degrees.
80 degrees. What about 80 degrees? They told me 80 degrees.
It's the same as
Ah, it's the same as x because the one that's across from it should be the same, shouldn't it? So that means that x is 80. Okay, what did you see next?
the same as y.
What do you mean, y?
They're slightly equal.
They're- So if these two lines right here, are parallel, and I know that because it's a parallelogram, then this line would be called a transversal. So what kind of angles are these two? Alternate interior. What do you know about alternate interior angles? They're congruent. Very good. So y is also 80. If you didn't see it or work it that way, that's okay. There's 2 or 3 other ways. Are we okay? What's another thing you thought about? Huh? Well, all of this has to add up to 360, doesn't it? Because how many triangles do I have inside here? How many triangles do I have? 2 of them. How big's a triangle? 180. So if I have 2 triangles, then I should get 360. Okay, that's good and all, and I'm okay with that thought process here. But I'm really looking for you to start thinking about things like this. If these 2 lines are parallel, what's this line right here? So what do you know about this angle and this angle? They're supplementary, aren't they? Isn't that what we just talked about right up here? Right, with A and B? They're consecutive interior angles. Okay, so that means that angle Z is how big? 100, absolutely. And the angle across from it would also be 100, right? And then right here, this is a straight line. How big is a straight line? 180. So if I wasn't sure that this one was 80 yet, then I for sure have a straight line. If that one's 100, that one has to be 80. Are we good? How many of you feel smarter already? Very good. I like that. Okay, 30 seconds, number 5. Go. Okay, quickly, what was the first one you did?
120.
120 where? Z, very good. The one across from it is 120, correct? Okay, what did you look at next?
120 or 35.
What about the 120 and 35?
Well, you add them up and subtract that from 180.
Why?
Triangle.
Ah, what he's looking at is he's looking at this triangle right here. And he knows a triangle is 180. So 120 plus 35 gives me 155. So 180 minus 155 is what? 25. So that means this one is 25, but they don't even ask me for that one.
Well, now you know the ones for the other side.
What other side?
The other triangle.
Which one?
Bottom one.
The bottom.
X?
Yeah.
How big is that one? Well, isn't it 35 because that one's 35? No. Good. Don't fall for my tricks, my shenanigans. Alternate interior, right? So the ones that are on the opposite side, this one should be 25. How big is Y? 35. Very good. Not falling for my tricks, y'all are learning me yet. Okay, 30 seconds, number 6, go. What about 70? You're saying that all of these are 70? Just the one across from it. What's that called when they're just across from it? What's that called when they're across from each other? What? Vertical angles. Very good. So what else can I do? Good. X is 30. Y? Good. They're alternate interior angles, right? Okay, now what? The angle next to 30. Next. This one?
Yeah, the X.
Right here? Right here? This one? Right here? It has to be what? Has to be supplementary to 30.
No, it got to be, it's 40.
What about Z?
It's 110.
Why?
Because, 70 and, X got to be supplementary because it's a straight line.
This is a straight line, so those have to equal 180, right?
Yes.
So that means this one is 110. How big is this one?
110 because it's a vertical angle.
Right. Now, how do I find Y?
Add 30 to 110. Yeah.
Okay. What shape do I have here?
A triangle, and it got to equal 180.
110 plus 30? It's 140. 180 minus 140
It's 40.
is 40. So Y is 40. That means that this one over here is also 40, right?
Yes, ma'am.
Are we okay?
Yes, ma'am.
I don't know these other angles yet.
You
Okay?
wanna know?
No, but I don't know them. Okay? Good. In your project booklet towards the back, we put that little blue paper that we folded yesterday.
Yes, ma'am.
I want you to copy these 4 characteristics at the top. Do you see how they just opened up that top piece?
Yes, ma'am.
Good. Listen to me. There's still a couple that I need to give you. So don't use all of your space. Leave me a little bit of space at the bottom. There's only like 1 or 2 more we're going to add to it. But these are the first four characteristics of a parallelogram, or properties of a parallelogram. Okay? Do we know now that opposite sides are parallel? Do we know that opposite sides are congruent? Yes, because on a parallelogram, isn't it just a crooked rectangle? And then opposite angles are congruent. And then the one that we just really hit hard today is that consecutive angles are complementary. Or we call them consecutive interior. Oopsie. All right, so we're looking at that same figure that we've been looking at. It asked me to find the length of DE. E was this point right here. It wants to know how big is that line. Well, let's see. The coordinate for D, wasn't that like -4 and 14 or something? And then I believe that point E is -7, 10.5. So I can do Pythagorean theorem. Remember where I go and I make that right triangle? So how do I get from -7 to -4? Isn't that 3 units? So that would be 3 squared. And then how do I get from 10.5 to 14? Isn't that 6.5? Oh, no, 3.5, sorry. 3.5 squared. Let's see, 3 squared is 9. What is 3.5 squared? 12.25? And if I add those together, I get 21.25. Take the square root of that. Well, let's see. 4 times 4 is 16. 5 times 5 is 25. Good. 4 point what?
4.5.
4.6. Well, how big is BE? 4.6. Why? Because they're the same. Remember, E was the midpoint. These two are the same. Okay, you have 30 seconds to figure out how big AE is. 30 seconds. So now I'm not finding AE. E is still -7, 10.5. A was at -4. So again, I'm still going to have 3 squared. But now I'm going to have 6.5 squared. So this is still 9. 6.5 squared is going to be what? 40 something, isn't it? 6 times 6 is 36. So do it. Somebody do it for me. 6.5 squared. What do we get?
Well, it's over 30.
42.25. Is that what you said?
Yeah.
Yep.
So it should be 51.25.
Yes. Square root
The
that.
square root, well, 49 is 7. 7 times 7 is 49, right?
So 7.3.
7.15? Is that what somebody said?
Yeah.
No?
I
But
said 3.
both of those should be the same. So what do you know about this? Are they all the same?
No.
No. What is that called when both sets are the same, but they're not the same? You wrote it on the bottom of your white paper. You wrote it at the bottom of your white paper. What?
Bisect.
Bisector. Very good. They cut each other in half. Okay. Watching this real quick. Okay. Naming parallelograms. Number 7 does not have a picture, does it? It tells me it's a parallelogram, so I'm going to draw it. Very, very important. They told me what it was called. Do not do the Z thing. Some of you, when you want to go and name a shape, you do the Z thing where you go like this to name it. X, Y, Z, W. That is wrong. Because it says diagonal X, Z. Is that X, Z? Is this a diagonal? Okay. When you name it, you go in a straight circle. Okay. When you name it, X, Y, Z, W. Now I have diagonal X, Z, don't I? And I have diagonal Y, W. It says they intersect at point A. It tells me that XA is 3B, and this one is 54. What do you know about those two? They're congruent, they're equal, so 3B is equal to 54. What's B? Wouldn't I divide by 3?
Yes, ma'am.
So B is equal to 18, great. And then it tells me that WY is 10B. So that means it's 10 times